This is 2020 paper 1 question 3. We're given two functions. We basically have to check if when we compose them one way is the same as composing them the other way. So let's check that. So first of all, let's do f of g of x. So that's equal to f of, and then g of x is the same as x plus 5 over 6. And that'll be the same as we take 6 times whatever the input is, which is x plus 5 over 6, minus 5. So I just took the function f and I replaced all the x's with whatever this is. Okay? And then we can just multiply it, so we get x plus 5 minus 5, because the 6 is multiplying and dividing by 6 is equal to 1. And then x plus 5 minus 5 is equal to x. So that's equal to x. Now let's see what is g of f of x. And that'll be equal to g of, and then what's f of x? It's 6x minus 5. That'll be equal to, so g of x, we take the input, add 5, and divide by 6. So we'll take the input, which is 6x minus 5. Then we add 5, and we divide by 6. So that'll be equal to 6x divided by 6, which is equal to x. So yeah, they're both the same. And in this case, they're inverse functions, because when you compose them, you just get the identity function x out. Then we're given this equation in terms of y and x, and we're told to rewrite it in this form, find the values of a and b. So you can see in their equation they have log base 5 on both sides. So let's just take this equation with y equals 5x squared, and let's just take log base 5 on both sides. So we have log base 5, and we have log base 5 here. And then we can just on the left side, can't really do much with log base 5 of y, and that's what we want on the left side anyway, right? Then here we have multiplication inside log, so we can change that to addition. That's one of the laws of logs. So we can have log base 5 of 5 plus log base 5 of x squared. That's just one of the laws of logs. You can see where it comes from as well, if you want, and it's in the formula tables booklet. Log base 5 of 5 to what power gives you 5? The answer is 1, or you can just put into your calculator. Then another law of logs is you can bring the power down to the front. So you can say this is 2 log base 5 of x. And that's still the same as log base 5 of y. So you can see now we have it in the form that they wanted. We have something plus something log base 5x. So a is clearly 1 and b is equal to 2. So a is 1, b is 2. Then we're told hence or otherwise find the values of y for which this is true. So the idea is this equation has x's and y's, but obviously we can't really solve it if it has x's and y's. But in the previous part we found out what log base 5 of y is. It's equal to this. So we can replace the left hand side of this with this, because it's log base 5 of y. So log base 5 of y is the same as, from the previous part, it's the same as 1 plus 2 log base 5 of x. And then according to this part of the question, that's equal to 2 plus log base 5 of 126 over 25x minus 1. So we can just take this part of the equation. We don't have to worry about the y's anymore. Now we have an equation which is x. So what we might do is we might bring the 1 to the right hand side, sorry. So on this side we'll have 1, and then I'll bring the logs all to the left hand side. So we're going to have 2 log base 5 of x, and we'll have minus log base 5 of 126 over 25x minus 1. A couple of different ways to do this. What I would do is if we have a log minus a log, we can just divide these two into a fraction, and that's nice and easy to work with. So that's probably what I would do here. But in order to do that, we need to just have 2 logs. So I need to bring that 2, get rid of this 2 in the front, but I can bring that up to the power. That's a law of logs. And now we can combine these logs since we have a log minus a log. So this is the same as log base 5 of, and then we're going to have x squared divided by 126 over 25x minus 1. And that's all equal to 1. This fraction's a little bit hefty. Now you could have just raised both sides to the power of 5 here. You'll get the same answer. But this is just the way that I thought I'd do it. So we'll have log base 5. I'm just going to multiply top and bottom by 25. Multiply this by 25. Multiply this by 25. So that's just multiplying by 1. Just make the fraction a bit nicer. So 25x squared divided by 126x minus 25. Because the 25 cancels with that 25. So you just have 126x. And then 1 times 25 is 25. That's equal to 1. And then we can do 5 to the power on both sides. So 5 to the power, 5 to the power. And then when you put a log in the power, it cancels out. So on the left side, we'll have 25x squared divided by 126x minus 25 will be equal to 5 to the power of 1, which is just 5. So now we can solve this quadratic. Well, I suppose before we solve it, it'd actually be nice. We can divide both sides by 25. Like if I divide this side by 5 and divide this side by 5, well, 25 divided by 5 gives us 5. So we're just going to have on the left side 5x squared over 126x minus 25, and that's equal to 1. So then we get 5x squared is equal to 126x minus 25, which means that, bring it all to one side, 5x squared minus 126x plus 25 is equal to 0. You might not be sure if this factors nicely, but you can kind of see something nice. When you multiply 5 by 25, you get 125, which is very close to 126. So factors of 125, well, you could do minus 1 times minus 125. That gives you 125. And that adds to minus 126. So what I'll do is, I don't think the ordering is going to matter here. So I'll just say 5x squared minus x minus 125x plus 25 equals 0. You could have just used a quadratic formula, but I've just rewritten this minus 126x. Then over here, I can take out an x, and I'll get 5x minus 1. And then here, I want my first term to be positive, so I'm going to take out a minus, and then we can take out a minus 25, right? And then here we're left with 5x minus 1. So then that factors to be x minus 25 times 5x minus 1 equals 0. And that's just taking out a common factor of 5x minus 1. So that means that x equals 25, or 5x minus 1 equals 0. So this is technically x minus 25 equals 0, x equals 25. And then the second bracket equals 0 gives us x is a fifth. So these are our two possible answers. But do they say find the real values of y for which this is true? So we have to just make sure that these actually work for real values of y. I mean, even if they didn't work, we'd have to check anyway, because these are the values for x. We need to figure out the values for y. So you could sub in here. It's a little bit messy, though. Easiest thing to do is remember that y is equal to 5x squared. So that's the nicest way to do it. So y is equal to 5x squared. So our first value is y will be equal to 5 times 25 squared. So that's this value of x here. And that'll give us 3125. So 3125. So that's one real value. And then the other real value then is going to be number 2. Y will be equal to 5 times 1 over 5 squared, which is just equal to 1 over 5. So it's important. They did say the real values of y. So we did get two values. So it looks all good.